we're going to look at a problem that involves confidence intervals or confidence interval estimate and proportions. So the problem that we're going to look at is one semester, the number of women attending a small college was 1,200 and the number of men was 3,600. What is the best point estimate of the population proportion for the number of women at this college? That's part A. And then for part B, we're going to use the data listed to find a 94% confidence interval estimate of the proportion of women at this college. So the first thing that we want to do is list the best point estimate for the problem. So part A here, and we're talking about the proportion of women at the college. So the number of women at the college is 1,200. So X is equal to 1,200. And the next thing I'd like to know is the total number of students this semester at the college. So the total is equal to the number of women, which is listed here in our problem, and the number of men. And so that gives us a total of 4,800 students. So our best point estimate, which I'm going to label as P hat, is equal to X divided by N. So that is the number of women divided by the total number of students this semester at this specific college. And if we simplify this, this is going to give us 1/4 or 0.25. So for part A, our best point estimate is P hat is equal to 0.25. Now for part B, we want to use the data listed to find a 94% confident interval estimate. So what do we need for this confidence interval estimate? So we want to find, if I write it in interval notation, P hat minus what we call the margin of error. E is the margin of error, and P hat plus the margin of error. And this would be the confidence interval estimate. So the formula for the margin of error is E is equal to Z alpha over 2, the square root of P hat Q hat over N. So what I need to do is I need to find each of these pieces in the margin of error formula. Well, we have P hat, so P hat is equal to 0.25, and that's P hat. Q hat is 1 minus P hat, so Q hat is equal to 1 minus P hat, which gives us 1 minus 0.25, which is a 0.75. So now we have our P hat, we have our Q hat, our total number of students is this 4,800, this is our N here, and so now I need to find this Z alpha over 2, which is the critical value. So we are asked to find a 94% confidence interval estimate. 94% confidence interval. So our alpha is equal to 1 minus this 94%. I need to put the 94% in decimal format. So recall, to put something in decimal format, I'm going to drop that percent symbol and move the decimal 2 places to the left. So 0.94. 94% is equal to 0.94. So alpha is equal to 1 minus 0.94, and that gives us 0.06. Now the critical value that I'm looking for is Z alpha over 2. So I want to take it a little bit further, and I want to find alpha over 2. So I have 0.06 as the alpha divided by 2, and that gives us 0.03. Now, this corresponds to an area. We have a normal distribution curve here. The area of 0.03, I'm going to put in this upper tail here. So that area is here. Remember, the total area under the curve is 1. So this area here is 1 minus 0.03 or 0.97. So at this point, you'll need to use your calculator, use some technology to find the critical value. The critical value is this Z alpha over 2. So Z alpha over 2. You'll need to use some technology to find the critical value Z alpha over 2. We have some calculator videos that you can watch to find the critical value, but a function I'm going to use is called inverse norm on the calculator, and I'm going to do inverse norm of this area 0.97. Now if I do that and I round the critical value to 2 decimal places, I'm going to get a value of approximately 1.88. So if I'm doing this on the calculator, if I'm working this problem on the calculator, I'm going to hold off rounding until I get to the very end of the problem. But for the purpose of the video, I went ahead and wrote the critical value to 2 decimal places, 1.88. So we have Z alpha over 2 is equal to 1.88. Now I'm going to go ahead and look at all of the pieces of the puzzle that I need. I need Z alpha over 2. I need the P hat, the Q hat, N, and from there I'll be able to calculate the margin of error. Well, here is our Z alpha over 2. Here is our P hat and Q hat. So P hat was 0.25, Q hat was 0.75, and N, the total number of students this semester at this college, is 4,800. So now I have all of the pieces that I need here. I'm going to go ahead and plug that into the margin of error formula and calculate the margin of error. So then I have the margin of error is equal to Z alpha over 2, so that's 1.88, the square root of P hat times Q hat divided by N, which is 4,800, and then I'm going to plug this into my calculator. So generally I do 0.25 multiplied by 0.75 divided by 4,800, and then I get that value, take the square root, and multiply it by 1.88. If I do that, if I plug that into the calculator, I'm going to get a margin of error of approximately 0.01175. Now that's the margin of error. So I'm wanting to compute the confidence interval estimate here. And that is the P hat minus the margin of error, the P hat plus the margin of error. So now I know my P hat, which is at 0.25, and I know the margin of error. So what I need to do is take the P hat minus the margin of error. So that's 0.25 minus that margin of error of 0.01175, and P hat plus the margin of error. And then the final answer here, if I do that calculation, will be approximately 0.238 to 0.262. And so the confidence interval estimate that contains the true population proportion with a 94% degree of confidence is 0.238 to 0.262.